All right, in this set of notes, we're going to be talking about another equation involving circles. In the last set, we talked about areas of sectors and how to find arc length using the arc length corollary. In this case, we're looking at the equation of a circle. Now, in terms of the equation of a circle, we're talking about a circle that's being graphed in a coordinate plane and has some particular center. So by the coordinate plane, remember that means we have our set of axes. So we'd have the y-axis and the x-axis. And somewhere in that plane, we have a circle graphed. Now the circle may intersect the axes. It may not. I'm drawing it as if it doesn't. Of course, we have the center point, and the circle has some radius. The center and the radius determine the equation of the circle. So the standard form or the standard equation of a circle is the quantity x minus h squared plus the quantity y minus k squared equals r squared. You may be thinking, what in the world do all those letters mean? Well, if you think about the equation of a line, y equals 3x plus 2, the y and the x just represent any point on the circle. So, for example, this point might be a point x, y. So any point on the circle is an xy point, which means the equation will always have an x and a y left in it when it's in its simplified form. Now, let's talk about h and k. The point h comma k is the center of the circle. And that would be this point here. So that's going to be the point h comma k. And of course, r is the radius. So this is going to be our radius squared. Now you may be thinking that this resembles the Pythagorean theorem, and that's because it is very, very much related to it. If we were to take a distance here, form the radius, we could base it off of this right triangle that's formed as well. All right, so ultimately, h and k is the center, and r is the radius. Now we have to be cautious. If h is a positive number, then this becomes x minus whatever that number is. If h is a negative number, then h minus a negative, this is going to look like x plus some number. So negatives make this become a plus. Same thing here. If k is a positive, then y minus whatever that positive number is. Whereas if k is a negative, such as, let's say k is negative 8, then this is y minus negative 8. So y minus negative, it's going to make that a y plus 8. So we'll have to kind of be cautious of that when working with negatives. Now let's keep in mind as well that if the center is at the origin, or if the center is on one of the axes, where either h or k or both are 0, then when h equals 0, x minus 0 is simply x squared. Here, if k is 0, then y minus k would just simply be y squared. If they're both 0, then we'll have x squared plus y squared. So there are a couple of different options that we need to look at in terms of the values of h and k when working with centers. All right, so continuing on a theme, let's look at some examples. Identify the center and radius of each circle. So in this case, because there is no value being subtracted from x, nothing that's visible, that tells me that the value of h must be 0. Likewise, in this y quantity, if y minus k is just y, then k must be 0. So our center, in this case, is at 0, 0. In the standard form of the equation, on the right side, we have equals r squared. So if 36 is r squared, then the radius will be the square root of 36, or simply 6. All right, looking at the second example, x plus 2 squared. Well, if I think about this as x minus h, I have to determine what value of h would make this minus become a plus. And that's what we were talking about before. If h is a negative number, then x minus the negative will make that a plus. So here, h, can't talk, equals -2. For the y term, y minus k, since the minus is still there, then k must be 7. And on the right side, 120 is r squared, so r will be the square root of 120. Now, it's okay with me if you leave that r as a square root value. Don't worry about finding the decimal. Don't worry about simplifying it. So our center in this case, h comma k, -2 comma 7. And the radius r is the square root of 120. So sometimes you'll be given the equation as we were in numbers 1 and 2 and asked to identify the center and radius. Other times you'll be given some values related to the circle, the center, the radius, a point on the circle, maybe a diameter. You're going to be given something about this circle and asked to write its equation. So with that in mind, let's look at numbers 3 through 6. All right, number 3, we're given the center as -8, 6. So h is -8, k is 6, and the radius is 14. So substituting into our formula, x minus -8. Minus negative is going to make that a plus. Squared plus, the next set of parentheses, y minus k. So y minus 6, quantity squared, equals r squared. So 14 squared is 196, which is going to produce the right side of our equation. Okay, moving on to number 4. The center is at 1021, so h must be 10, k is 21. We have a point on the circle this time rather than the radius at 15, 9. Now, if you consider the fact that the radius is the distance between the center and any point on the circle, then r is simply found using the distance formula. The distance between these 2 points, the center and a point on the circle, is r. So our distance formula, r is the square root of, take the difference of the x terms squared, 10 minus 15, quantity squared, plus the difference of the y terms, 21 minus 9, quantity squared, and all of that's under our square root. Now, when it comes to simplifying this, for now, don't worry about that square root. Type all of this with the parentheses into your calculator. So in that case, parenthesis 10 minus 15, close parenthesis, squared, plus parenthesis 21 minus 9, close parenthesis, squared, equals. So in this case, I get the square root of 169. Now, in some cases, the square root will be a nice, pretty whole number. Other cases, it's going to end up being just a square root. When that's the case, leave it as a square root. It's not going to matter. Reason why. In our equation, for the standard form of a circle, we take x minus h. So in this case, x minus 10, quantity squared, plus y minus k, y minus 21, quantity squared, equals r squared. Now, if this is r, what happens when I take r and square it? When you take the square root of 169 and you square it, you get 169. So don't worry about simplifying these square roots, because once you square them again to get your r squared value, it's going to be a whole number. In this case, we get 169. All right, number 5. Working with some transformations. We take the equation x minus 6 quantity squared plus y plus 13 quantity squared equals 16. And we're going to translate it down 5 and right 7. So if I think about where the center is at this point, x minus h means h must be 6. Y minus k, in order for that to be a plus, k has to be a negative 13. Whoops, no, that's not a y, that's a k. Wrote the wrong letter. Now let's think about it for a minute. If you translate an object, it does not change its size at all. It changes its position, which means the radius is not going to change at all. We're only going to change, where does this center go? the radius will stay the same, and that'll determine where the points on the circle end up. So if I go down 5, is that going to change the xh value? Or is the down 5 going to change the y value? Should change the y value. So in this case, we're going to go down 5 from negative 13, which is going to put our k value at negative 18. Here we have a right 17. A right motion is going to affect our h value, our horizontal value. So if we go right 17, it's going to add 17 to that 6, which produces an h value of 23. So the equation of our circle, we now have a center at 23, negative 18. So x minus 23 squared plus y minus negative, it's going to be a plus 18 squared, equals r squared. And we said the r value didn't change, so the 16 is going to stay the way it is. And the last type of problem we're going to be looking at, here we're given two endpoints of a diameter. That's telling you two things. First of all, we know that the diameter passes through the center, and that the center point has to be the midpoint of that segment for that diameter. So I need to determine what is the midpoint between these 2 points. So the center of the circle is the midpoint of the diameter. Now, do we remember how to find the midpoint of a segment given the coordinates? Midpoint is average. So the center in this case will be the average of the x coordinates, add and divide by 2. Remember to use the two x values together, negative 2 and 4, and the average of the y's. Add the y's, divide by 2. So what does that put our center at? Let's see. Negative 2 plus 4 is 2. 2 divided by 2 is 1. 6 plus 12 is 18. Divided by 2 is 9. So our center is at 1, 9. Now what this should resemble once we find that center is a problem much like what we had up here in number 4. We have the center point and we have a point on the circle. So we want to find the distance between them to determine the r value. So back to our distance formula. I'm going to use this 4, 12 and this 1, 9 because I don't want to mess with the negative. All right, so 4 minus 1, difference of the x's squared, plus the difference of the y's, 12 minus 9 squared. And there again, I'm not going to worry about that square root so much. Let's just type all of this into the calculator. Don't forget your parentheses. 4 minus 1 squared plus parenthesis, 12 minus 9, close those parentheses, squared gives us the square root of 18. Which means r squared for our equation will be the square root of 18 times itself, or 18. Now to the equation of the circle. X minus h1 squared plus y minus 9 squared equals r squared, or 18. So that takes care of how you are going to work with finding the equation of a circle, or given the equation of a circle, can you find the center and the radius?